Hello. Hi, everybody. Thanks
Hey,
for
guys.
joining the Scale Community Technical AMA. This is actually a technical AMA this week, or this month. We've gotten a ton of technical questions. So Stan and I thought it would be great to get some other team members here and let people meet more of the people that are getting their hands on the computers, building code, contributing to the open source code of the Scale network. So we've got Artem and Dima here. Hey, guys.
Hey.
Hello.
And I believe most of you know Stan.
Hey, guys.
Say hi, Stan. Okay, well, we're going to get into it. Per usual, I'm going to give a quick intro and summary. So in the last month, we've crossed 73 million total transactions since the commencement of Scale V2 last June. We have $1.246 billion in gas fees saved on Scale. It's massive. Just a lot of great work by a lot of people. Props to all the validators. We always have to give the validators props. The core team and the community developers and the dApp developers don't run any nodes. They're all run by a decentralized validator community. So props to those folks for running such a kick-ass network and doing almost $1.25 billion in gas fees saved. Okay, we now have 20 live EVM chains. We had 4.7 million transactions last month. So that was down a bit. I think we're seeing in general over the last month a lot of just drop in transactions across the entire industry. But still 4.7 million is something we're proud of. And we know that, collectively for us to keep growing, we've got to keep adding more and more applications, getting more and more users, and just fight through any sort of down cycles where there's less people playing and getting on Web3. But my personal feeling is this industry is just getting started, and we're just at a drop of the bucket collectively in terms of the total transaction volume we're going to start seeing in Web3, especially for high volume, low cost transactions. Okay, we have now crossed 425,000 total unique users, and last month we had over 25,000 active users or active wallets. Okay, so again, I think we all want to see that number be higher. It's been higher in prior months, and again, we got to just keep growing, and those things are expected, though. It's all part of having like real data piping through the blockchain. Centralized companies have this luxury of having their own private data, but open source community owned projects, we all can see the data together, and we know we can, and it's great. Transparency is a way for success and growth. So all right. But anyways, I'm feeling excited because we have had a ton of new announcements, and there's a lot more coming. First off, the Scale voting proposal was submitted. This is an open source initiative. I've said this so many times. We're not trying to control this from the core team. We're helping as a core team member and a founder, trying to really help nurture it and guide it. But you can go see that proposal. We're looking forward to seeing actual code. It's got to get put into code, and maybe Artem can give an update. I know he knows people working on that, and he's helping contribute to that. And so we can codify that and get the first vote ratified. The goal is to have it ratified by today. It's still not in place. I'm hoping it'll be done in the next week or so. And again, this is not a centralized driven initiative. If we were just doing it, we just said, boom, here's voting. This is how it all works. Everyone must comply. But we're trying to get a lot of people involved, getting a lot of opinions, and having people contribute to building it who aren't just core team. Okay. All right. We had a big launch with Untitled platform and just a really fun game. One of the cool games that I've seen. So you can go play that today. That happened last week. Big announcement with Bionic Owls. Next is Metaport. We're going to learn more about that, but we're seeing Metaport, come into the world, and Metaport needed it's been built for a long time, but it just needed the right type of, I would say, legal structure so it can operate in a way that, because it's a website, it's a web UI. Even though all the processing is done on the blockchain, there's still, still takes people or companies to get Metaport up and running, and so there has to just be some legal terms, which you'll see when you use it. Okay. All right. NFT Moon Metaverse was, announced that before. We did a big spotlight with them, and excited about that. Flight Force 4 Big game, big announcement around that. And also OIX social media and Rebel had two major announcements on that, and exciting about that big launch. And Rebel is one of the most actively utilized decentralized social networks. They're doing some really cool stuff with NFTs and creating a hyper engaged creator network where it's Instagram built for creators by creators. So that's really cool. And so there's more good stuff coming. And again, props to everybody. I know a lot of people here are listening, or people who are working on the project, and always want to share the the success comes from a lot of people and a lot of hard work. And so keep up the good work, everybody. Okay, without further ado, we're gonna get into AMA. All right. Again, I thought it worked well last time. We're gonna try to answer as many questions as possible. So this is from Naber. Where are you creating your contracts? Hard hat, truffle, or remix? Okay. Artem, we're gonna let you answer this one.
Yeah, for sure. Like initially, we like when we start developing some smart contracts, we used truffle because like it was like one of the popular like smart contract to like back in 3 or 4 years. But then we switched to hard hat because like hard hat has a lot of like nice plugins which you can turn on into your project, and we are using also ethers because like ethers provide you much more stable connectivity to different endpoints. And also, like we are all recommend to use hard hat and ethers to connect to Scale as well. Yeah. And also, like I remember, like for some small projects, for sure you can use Remix just like to develop like 1-2 smart contracts. But for big, it would be much more useful to use hard hat, like full coverage testing and.
Awesome. And one of the key takeaways there is just if you're building on Scale, if you want to build something, deploy it on Scale, you can use what you can use for EVM. It's, you're running Solidity contracts, and Scale also uses Solidity contracts in Scale Manager on the Ethereum mainnet, where, core dev contributors like Artem have, built some really kick-ass or contributed some really kick-ass code. So, but that was a good question because it, shows that we're hyper compatible. Someone could build something on Ethereum and meet, Scale a week later and deploy on Scale without any, almost zero additional work other than obviously SQL input tweaks. Okay, thank you, Artem. All right, this one's from Flensman. Our love Flensman. All right, regarding governance for the staking proposal, will custody staking providers like like centralized exchanges, for example, be able to abuse their voting rights since these tokens are never actually in the customer's own wallet? And could they therefore offer huge staking rewards for customers who can give up their voting rights for profit? Well, super smart question. This was really discussed in depth amongst all the validators and dApp developers and community members I spoke with, and the different people that are game theorying out the model. The good news is we don't have to invent this from scratch. You look at the proposal was brought forward, looks very similar to other decentralized networks, staking networks. Now, the beautiful thing that we have going for us, the really good thing we have going, is that in order to stake on the Scale network, you have to be staked for 2 months, okay? So let's say you look at the largest wallet in the network. If you go to Etherscan, is Binance, all right? And in, of Scale token holders. But Binance only has a couple nodes, so there's only 40 million tokens staked or something like that. And so Binance, yeah, even though they're the largest token holder, their voting power is actually only voting power of staked tokens. So if Binance wanted to stake a lot more tokens, one, they'd have to lock them up for a bigger period. They'd be locked up for 2 months, which means they'd have a lot of aligned interests with the network. Now, if we only had a 3-day period of staking, you could have people pull off some effective attacks to submit a proposal, block a proposal, do some nefarious things that aren't good for the broader community because they have such a short lockup incentive. On Scale, they're locked up for so long. If you push something bad through voting, well, you better be ready to live with those results. So And I think, these centralized exchanges, my experience with them is actually, I think the vast majority of them are really good actors and they want the best for the industry because they win when the industry is winning. That being said, you still don't want them to be able to control decentralized governance and impact, the future of dApp developers and validators in a negative way. So I think all those mechanics together give the voting proposal that Axios brought forward a lot of defensibility against a nefarious centralized exchange attack. Stan, you want to talk about that?
I just want to say that, I think when we started, pretty much every project that starts centralized. And so we started centralized. But at this moment, we are really in a position where we actually can decentralize to the maximum because the product, the network runs, it works pretty well. We have some bugs, we have some new features, but what we realized is that we are at the point where we actually can decentralize now, not just wait for later, but we're aggressively pushing the community, basically decentralizing everything. And I think as far as who can vote, it's like, for me, I don't personally have answer to every question. I think the perfect scenario for a network is basically a collection of people, because computers or servers are run by people. So ultimately there is nothing except people, right? Software doesn't have an identity. So the perfect network is just a collective of people that is somehow able to make effective decisions, and also is fair in the sense that if you contribute somewhat, then you get something back. And so basically that's the goal. But I think the current proposal, there was a proposal made, and it's just a start, in a sense that we really appreciate if anyone has a different opinion or contributes, there's a discussion. So the current proposal is just something to start. Actually, for instance, people have different ideas. For instance, I had this idea, I don't know how good it was, that maybe we also allow not only our token to vote, but if there's an app and they have a token on Scale, we allow them to vote. But this idea wasn't really, I think most people didn't really kind of think it's interesting. So there are many ideas, and I just encourage everyone to contribute, because at the moment there's a proposal, but nothing is set in stone, and we literally don't know how it's going to end up.
Yeah. And one cool thing about it is this proposal was selected for its flexibility. I'm not saying it's not selected because it hasn't been selected yet. It's still, you can get on forum and give your thoughts and opinions, but the reason it has gotten this far through all the people is because it's meant to change and evolve. There's a lot of interesting things happening with governance, but sometimes projects do something really complicated at first and then they get stuck, and then it's hard to go back from that. And so this is meant to not make us stuck. It's meant to make us modify and grow easily, and the structure itself can change. Okay. The other thing I want to say regarding decentralization, so this obviously started as an idea with a couple people, Stan and I. So that was pretty centralized, just two people, and then some other, Artem and some other engineer, Dima, and a handful of engineers, all of us together, and and that's not very decentralized. Back in end of 2017, beginning of 2018, and it's really, by the time we launched in 2020. We hit this milestone of huge decentralization where we didn't run any nodes. We didn't run any of the software. We weren't in charge of things, and money was in a foundation. There's all these, decentralized initiatives in place, but the voting and all the network approvals ever since then were done by all these different multi-sig parties. But, we really, I think it's evolution of decentralization, and every project goes through this, and people that try to, I think, go to 100% decentralization on day one, they kind of don't get anywhere, because decentralization slows you down, unless you're Bitcoin. That was pretty amazing. But in this day and age, you see a lot more centralization and you almost call it like evolved decentralization. But I think Stan made it clear, and I want to also make it clear, I think it's imperative to our success to get even more decentralized and get even more people involved. And we're already making a ton of progress there, but the more we can do that, the faster we'll grow, and the more engagement we get with the developer community, the players of games, the community that staking tokens, the validators. So governance is a huge step, and I'm excited. I'm commenting on the forum. I think everyone sees my thoughts. I'm ready to push this thing live ASAP, and hopefully we can see the code pretty soon. Artem, you're working with some people working on the code. Do you think we'll be seeing a proposal and snapshot of what that looks like soon?
Yeah, just for an update, like basically by today, the snapshot strategy is finished, and it would be approved by snapshot guys in GitHub very soon. And I hope like we can set up something like in the beginning of next week, like on Monday, because like snapshot strategy should be added to the actually all the collection of the strategies, and we can set up.
Okay, so I think that's good. I think we've got to take that code too and get it in front of the different validator communities, developer communities, get it in the forum, and have people look at it, review it, give last pieces of feedback. And personally, I'd love to see that first vote go through to ratify the voting structure and the first week. And basically what it is these voting structures have thresholds. And so there has to be a positive vote to approve the voting structure. It's kind of like we're going to literally vote to approve our voting. Kind of circular, but I think it's needed. Okay, thanks, Artem. All right, next question. Stan, this is from Bondarvik. Can you please explain the consensus mechanism used by scale chains? So we have a lot of new
yes.
people here. You've talked about this before, but there's a ton of new people. So sorry, this will be repetitive, but go for it.
Totally. So basically, the simplest explanation, I'll start like a little bit in history, right? So when like Steve Jobs or like the first computers happened, even before Steve Jobs, even before PCs or like Apple computers, they were like mainframes, and people essentially tried to find out why computers are useful. And initially they did some scientific stuff on computers, but they wanted to find out how to make them more useful for like just regular people. And basically, almost immediately, the most useful application, the earliest application of computers was banks, right? Like instead of like having books in a bank, you actually put the information in a computer. And that's the notion of database, essentially. The database, or how database is historically started, was that it comes from banks. You need to be able to store information. And then once like it started, banks realized that the databases need to be replicated. And so almost immediately, because if you just have a single database, if it crashes, no one knows how much money anyone has, right? So almost immediately, people wanted replicated databases or clustered databases. And then essentially, that's how the company Oracle started. That's how they became successful, because what Oracle was able to do is create this cluster databases. Although, like, I think they didn't really know about mathematics at Oracle at that time. They were just, there was so much of a market need that they somehow built something that was replicating. And we have Oracle now. It's super successful. Many people, I don't think, like, it's not open source. People don't know how it works at science, but it replicates, right? So basically, the basic notion of computer science is a replicated database. It's like, if you have like 10 locations in your bank, each of them has to have a copy of your bank account, because if you come to a particular location, particular branch, you need to be able to withdraw money. So there's the replicated database. Basically, blockchain is a secure replicated database, which is mathematically clean. Now, in order, if you think about like a secure replicated database, how to do it, you start understanding one interesting thing is that if you have multiple locations in your bank, then transactions need to be ordered in the same order, because otherwise you can have a double spend. if you have $100 in your bank account and you write 2 checks, one to Alice and another to Bob, both for $100, one of these checks has to clear and another one has to fail because you only have $100 in your account. And so there's a notion of ledger, and ledger used to be on paper. Basically, you say, I pay $100 to Alice, and then you say, I pay $100 to Bob, and the first transaction actually clears and the second one fails. But for this to happen, the ledger has to be the same. The paper ledger or the computer ledger has to be the same on every location. So actually, blockchain is a super simple, it's just mathematically provable replicated ledger, which is mathematically provably identical on every node or in every geographic location. And it turns out this problem seems to be pretty simple. Turns out that it turns out to be a very complex mathematical problem. And the reason why it's complex is because in a blockchain, you assume that some of the nodes are malicious, or people call them Byzantine. So they can do whatever they want. They can lie, they can pretend to be honest, all kinds of things. So it turns out that replicating ledger under assumption that some of your participants are bad and you don't even know which of them are like liars, turns to be pretty hard mathematical problem, but it's actually solvable. And it was solved in a very ineffective way. The first time it was solved in 1982. There was a paper from MIT. There was several persons. There was Barbara Liskov, who is a professor at MIT, and they got the Turing Award, which is like a Nobel Prize in computer science for solving this problem. But the solution they had in 1982 was not super efficient. But then there was a progression, and there were papers and papers and papers. And so when the Scale started, we basically looked into the scientific literature and picked up something which is the most efficient. It's like from academia, comes from academia, and people just say it's efficient. You can prove it's efficient. So we took the consensus, which was developed by a French scientist. He is now at the University of Nantes in France. And this is it was 2015 paper. It got like an award, the computer science. And at the moment, among different consensuses, mathematical consensuses, it's considered probably one, if not the most effective, but one of the most effective ways to do consensus. So that's how we do consensus. We basically took things from industry and we built the exact implementation of this paper and other papers. I'm just mentioning one paper. But the point is that because we actually all based on academia, we can say without being scared that we are probably secure. And people come to us and say, why are you guys secure? We actually send them to the papers. It turns out you can prove that a ledger can only be secure under assumption of less than 1/3 of participants being but Byzantine or malicious. So we are secure under this assumption. And that's actually also what differentiates us from other blockchains, because we are based on provable things. What it means in real life is because our blockchain is provable, if something goes wrong, we can just look in a particular paper and a particular cryptographic algorithm and understand where the bug is. While if a blockchain is not provable, is secure, is not mathematical, if something goes wrong, it's like pauses. And people don't know what happens because there's no paper. It's never written. I don't want to give so much examples, but Solana, for instance. I mean, sometimes Solana crashes, right? And you can't really say for sure why it crashes because there's nowhere document which says that's how Solana is supposed to work. And Bitcoin, when it was released, it was probably secure in a sense it was a mathematical paper. Ethereum, the mainnet, is secure because we know the specification. Unfortunately, not all of the blockchains are actually probably secure, or there is like an open source specification of what they do. And that's actually what is good for us at Scale. And I think that's something which allowed us having a small team to produce results fast, because instead of us like basically inventing the wheel, we actually took this academia stuff. That's a short answer.
Okay, nice. We'll do the long answer next week. How about that?
Okay. Yeah.
Podcast on it. That's
I'll be happy. Just sorry to interrupt you, Jack. Guys, and then there are many things. I just don't want to go into much detail. But if there are some specific questions about different stages, one thing which I want to mention, which is really interesting, we have some new engineers joining us, our community, our open source project, and just a couple of weeks ago, some of them asked us to update the documents, how consensus works, makes them more readable, because the more readable our documents are, it's easier for open source community to join us. And so we actually updated the document. Me and Chadwick Strange, our community leader, we did it together with him. And there was a pull request, which I think the last one was a couple of days ago. So there is actually a link on our, if you go to GitHub, Scale Consensus, there's a link. And if you click on this link, there is a spec, how our consensus works. And we just updated it recently, just for the purpose of explaining to people in an easier way, everything, all of the mathematical stuff. So it's still not perfect, but we are trying to improve it constantly, the document.
Awesome. Good stuff. Good stuff. Thank you, Stan. Great, great answer. Okay, here we go. Vital G. How does the Scale network ensure the security of Scale chains? I'll answer this. I'm going to answer it briefly. So I'm going to try to answer this in the most concise way I've ever answered it. Okay. So Scale itself is secured by the Ethereum mainnet because it's a proof of stake network that has a stake into another network that's bigger. Okay. Then there's one set of validators in Scale. This one set can be coupled into smaller sets called Scale chains. The cool thing is each one of these Scale chains is really fast because of Scale consensus, but it's really secure because it has one set of validators below it that help it share security. And it has security that's shared with the Ethereum mainnet, but in a way that is good for Ethereum, it doesn't override Ethereum shared security, because Scale's the token being staked. You're not restaking ETH. And so what happens is you get a smaller set of validators that's part of a bigger pool, and it would require probabilistically 2/3 of the validators across the entire set to be bad in order for one small set to break. And the penalties at the end of the day are held on Ethereum, not within this set of actors. Okay. Which, if the penalties and the rewards were also in that set of actors, there could be no repercussions for baddies if they were able to manipulate a chain. So one, the math makes it difficult. The incentive structures make it difficult. And the incentive structures are protected by Ethereum, as well as are the way that these sets of chains are orchestrated together. They're also protected by Ethereum. Okay. I don't know if that's the shortest I've ever done, but I tried. Artem, you want to add to that?
Yeah, I just want to add that basically I have some jokes that Scale Network is a DApp, basically. And we have a big set of smart contracts deployed on Ethereum, which called Scale Manager. And every Scale chain controls by this set of smart contracts. Would it be reorganized by node rotation? Would it be rerun the DKG, etc.? Everything organized by Scale Manager. And if something bad happens on Scale chains, for example, one of the node is not performing enough, it would be we have some plans to add some monitoring stuff to actually send the information to the smart contracts, and the smart contracts will analyze it and will penalize some of the validators. So basically all the stuff which is happening bad on Scale chain would be known in the smart contracts, and smart contracts would decide what to do.
Yeah, I had someone once, I think they're saying Scale Labs is making chains, and like a couple people are together, oh, let's make a chain for somebody. These validators should work together. No one makes chains. A smart contract on the Ethereum mainnet, if you go to the contract, you know how to interact with it, pay ETH, run the process, you can have a chain deployed, okay, and pay Scale, okay? So also I have to say that the evolution of that payment mechanism is also about ready to, I think, go into next level awesomeness when it comes with on-chain voting too, so we can get new economics approved. But yeah, the Ethereum mainnet and these contracts are really like a dApp. All the functions have to be controlled by Ethereum, and we can't be like, oh, let's remove this validator and switch another one in. It like actually takes time because all of these smart contracts have to fire and security has to be run. Okay, thanks, Artem. Our question from Barry. I'm going to say a good question because I know John on our team loves when I say another good question. All right, so does the newly launched Metaport bridge in any way relate to the SKALE AMA bridge? So D1 here, we call Dima D1 because there's 4 people on our core team named Dima, and Dima was the first one on the team, so he's D1. Dima is one of the lead engineers that's been working on Metaport. Can you talk a little bit about that, Dima? Maybe talk a little bit about Metaport too for people who don't know what it is.
Yep, sure. So just to give you a general understanding of our interchain transfers, how it works, the overall architecture, really short, as your previous answers, really short architecture overview. So basically, we have a set. So what is IMA? We have this piece of smart contracts that lives on the Ethereum mainnet. So Artem mentioned we have Scale Manager, which is one set of contracts that manages the Scale network, and we have another set of contracts that manages the interchain transfers. So we have smart contracts component that lives on the Ethereum mainnet. Then we have a part of IMA contracts that lives on a Scale chain. So each Scale chain also have a set of pre-deployed contracts that handles on-chain side of this transfers between Ethereum mainnet, Scale chains, and between the Scale chains. So we have these two sets of smart contracts, one on Ethereum mainnet, one piece on each Scale chain pre-deployed. Then we have a part that's running on the nodes of validators. So for each chain, we have 16 IMA agents. That's the Node.js container that runs on each node that participates in an S chain, and this IMA agents actually performs all of the transactions on both on the mainnet part of IMA contracts and on S chain part of IMA contracts, and actually performs all of the transfers. So with that in mind, that's the core architecture of IMA that actually performs all of the transfers, that allows these transfers to happen. Then we have different layers of abstraction for these contracts. So the lowest level is you can go to EtherScan on mainnet and fire a transfer, or you can go to Block Scout to the Block Explorer for any Scale chain, and you have all contracts verified on all chains, and you can just go there and fire a transfer transaction. But that's the very low level. So basically, nobody will do that. We have a bit higher level of abstraction. We have a TypeScript library called IMA.js that abstracts out these transfers a bit. So this layer of abstraction is mostly for other dApps who wants to integrate interchain transfers, and they have JavaScript or TypeScript based app, which simplifies this transferring logic for them. Then, on top of this IMA.js library, we have two UI tools for one of them is for dApps and one of them is for the end users. So first one is the embeddable widget for the websites. It's called Metaport widget. So that's the piece that you can easily integrate into your website. It works pretty much like for Zendesk. If you ever saw this small pop-ups in the right bottom corner of your screen that says do you need some help on this website? It basically works in the same way, but it provides this website. It has the functionality of the interchain transfers. in this small widget. And this piece is mostly for our DApp partners who wants to utilize this interchain transfers in their DApp, and they want this easy plugin added to their website. So that's one solution. And then what we've just announced yesterday is the full-fledged Metaport bridge. That's the static website that is the highest level of abstraction. That's the tool for the end users. That's the place where the regular Scale user can go and transfer his tokens from mainnet to CryptoBlades chain, or transfer Ethereum from Ruby chain to NFTrade to buy some NFTs. So that's all of the layers. We have core layer with smart contracts on both sides. We have IMA agents running on validators machines. Then we have JavaScript library that abstracts out this transfer interactions. And then we have two tools built on top of it. We have Metaport widget and we have Metaport bridge. So that's how this Metaport bridge fits into the existing infrastructure. Hope it's clear.
Nice. Well, I think it'll become more clear to people as they start using it. So, you think about it. I think Uniswap's a good example. If you go to Uniswap or Ruby Exchange, let's say Ruby Exchange, because that's the exchange on Scale. Well, there's a UI layer. That UI layer is just letting you interact on the back end with a blockchain, but the blockchain is actually doing all the work. It's kind of doing this handshake to get, like your human brain, and you're seeing, if you're not an engineer and you don't want to go to Etherscan and like input code or like, hard numbers, you can just use an interface and, tell an interface to do something. But the reality is that you're then confirming through MetaMask or some sort of encryption device to then, do a handshake to say, yes, I do have the private keys to send this money or swap this money or approve this token to do this thing in this contract. And that's really what Metaport does, is it doesn't let you swap tokens. It just helps you bridge. Just like a Uniswap UI helps you trade and swap, or a Ruby UI lets you trade and swap. Metaport does the same thing, and it's really abstracted away. It's just a surface layer on what is happening below, which is a blockchain.
Yep. And the thing worth mentioning that for the Metaport bridge, we're not hosting anything on our backend. We don't have any backend for the Metaport bridge. So that's just a static website that performs the calls and transactions to IMA smart contracts. So there is nothing in between user and the actual smart contracts. We don't have anything on our end.
Okay. Awesome. Thank you, Dima. All right, Stan. How does Scale achieve horizontal scalability and high throughput in its blockchain network? Can you provide insights into the underlying architecture and mechanisms employed to handle the increasing transaction volume efficiently? This is from Dilip. You're on mute, Stan. Can you hear Stan? Artem?
Yeah, I think I can start.
Go ahead, Artem. Why don't you handle this? Stan, your sound doesn't work for some reason.
Yeah, basically, like by the architecture, Scale Network, it is so we have basically unlimited power to unlimited
Capacity.
To add the nodes to the network. Basically, I would say that there's like a equation with several params. For example, like we have a minimum staking requirement, which is currently 20 million you need to stake to create a node. If, for example, we can divide it by 2, it is possible to create double the amount of nodes. We have parameter like number of parts which each scale chain is operating on the node. Basically, we have like medium chain is operating on 1/8 of the node. We have large chain which is operating on one full node. We have like small, also like an ability to create a small scale chain. And if we can take all of these params together, we can see that it is like basically unlimited capacity to create scale chains. And how we can do it? We can divide by 2 MSR. Divide. Oh yes, then we can hear you. Yeah. Let me finish and I will pause everything. We can divide by like.
Sorry, guys.
Incrementally divide the MSR, and the capacity of the nodes would be increased. That means that capacity of scale chains would be increased, and so and so and so. Yes, then if you want to add something.
I think Artem pretty much answered it. I don't want to repeat. I just want to say that from the beginning, we actually targeted, we understood one simple thing is that, we need to have more than one chain. And as Jack sometimes says, we were a little bit in the future when we started, because everyone was like doing a single chain. But we just, it's a very logical thing to say. Then, and if many people use blockchain, it will need more chains. And so we, from the beginning, started. And the funny thing is, like, the industry is like catching up, and the users are catching up. But now we're really in good position, I think, because Jack can talk a little bit about like people, the new potential kind of communities that come to us, and we see like the early, especially like early stage startups, the early stage people, they really need lots of chains, because I think it's really logical that imagine like you are in a subway and everyone around you plays a blockchain game. Right? You just think yourself, is it all going to be played on the same blockchain? Probably not. So we had this vision from the beginning. I think the industry is growing, and but now I think we're doing pretty good because people are already using us. But in the future, they will inevitably need more of those chains.
Dan, this is that I think a good segue into on Andrzej's question. Andrzej, ANDRZEJ. Okay. Who's a really strong community member who's always involved, asking great questions. So what is the maximum number of scale chains that are with the problem? We have 20 chains running currently. There should be more coming in the next weeks, months. Are we prepared to grow 10x, 100x? Is 1,000 chains even doable? What kind of changes the platform do we make to get 10x growth, 100x growth? I'll give a quick lead in that it's all, there's a different levers, okay? One lever is how many sub nodes each node can, be split into. Right now it's setting as 8, but if that were 128, then you could have a lot more chains, but you'd have a lot more, I'd say, less powerful chains, like mini chains. The other one is like getting more nodes in the network. So you could get more nodes in the network by decreasing the MSR, which would motivate validators to set up even more nodes. Or you could, just more people stake, and that works in conjunction with the MSR, the minimum stake requirement. And so, so the number of chains is really, based off this equation of number of stake tokens, number of subnodes in each chain, number of and then the third variable I referenced. So those things collectively dictate, I guess the MSR. They dictate the number of nodes in the network. Now it's all a game theoretical thing of economics of making sure that the right amount of supply is there to match the needs of the validators and the needs of the DApp. And the needs of the validators are in their operational cost. So if the MSR is like 5 million instead of 20, well, they're going to be, have run a lot more nodes for the same amount of return, unless there's a lot more return and there's more demand to buy chains. Okay. And there's also a linear price curve on chains. All these things work together in harmony to try to dial the economics in to match, the needs of the network. Now, so I hope to see there be thousands of chains or hundreds of thousands of chains someday, but it's all going to be like, what are the needs of the developer community and what are the needs of the validator community? And then what do people want to do with governance to try to set these parameters so that both the dApps and the validators are happy? Okay, any other thoughts, guys?
I just want to add, Jack described the community part. Basically, there are two parts. The community part, how many nodes we run, and then there's like a pure engineering part, how many chains we can run on a single node. And so with every release, we are improving the memory and the CPU requirements, basically making our nodes more and more lightweight. And it's like a standard Amazon virtual machine. So if we can like shrink the memory requirements and the CPU requirements, we can run more chains. But then there's like, first of all, the algorithms are complex. We cannot make changes fast. In some cases, we know how to improve, but we are trying to gradually, with every release, to introduce changes, not to break things. And in particular, 2.2 release is going to be another iteration of major improvements, especially in memory. For the core consensus, we just ran like a couple of weeks ago some tests. We're able to run core consensus like on 50 megabytes of memory. And then there is now lots of work done for the transaction queue, because lots of memory is taken by transactions in the pending queue. And there's a huge number of changes now coming in release 2.2. So it's all improving with every release, and we know how we'll be improving. So it's going to be a multi-year improvement schedule, because we don't want to break things. But one interesting thing is, like, even outside of our core network, just very speculative. I was like a couple of weeks ago, I was like Googling and trying to find what is the cheapest virtual machine you can run. And I think on AWS there is like this nano machine. It's like $7 or $6 per month per machine. So if you run 16 of them, it's like $150 per month. So if we are able to run, no, not inside of our core network, I'm just talking about more speculative stuff, just for fun. If we're able to do it, then I think with release 2.2 as experiments, we could experiment with running our chains on an even more memory constrained environments and CPU constrained environments, which opens us up to things like IoT, Internet of Things. Because imagine like your web camera runs blockchain, or some stuff in your home runs blockchain, and they form a blockchain together. So there are really interesting things. If we continue improving our memory footprint and our CPU footprint, then we could like think about something totally interesting for the community, going in particular in the world of IoT, or like super cheap chains, like people run like in a super constrained environments. But for the main network, it means more that our validators are used to run a particular type of a node, a particular set of CPU requirements and memory requirements. So we're not actually changing that. But if we're able to actually shrink memory and shrink CPU, ultimately we'll be able to run more of those things. So engineering is constantly like working on that side. But there's a separate side, how do we make community run more nodes? And one thing which was also one which will also, there's some ideas in the engineering team about like how we make our validators, how we create like new business models. For instance, like currently each validator is paid essentially the same amount and every node is standard. But what if I actually do want to pay to my validator a little more to be faster? I'm like a DM community, and I just want to like pay a little more. There's currently no mechanism on any proof of stake chain to make a more flexible business model, economic model. So one really interesting thing which we were thinking about, it's just like vague ideas at the moment, is that there was a proof of work, now there's a proof of stake, but the future is probably like proof of stake plus something more flexible, because you need something which takes into account more of different people want different things, different dApps want different things, and different dApps want to pay different amounts, right? So how do we make our network more flexible? How do we create additional revenue sources for the participants? And if we find additional economic ways for them to make money, this I think can contribute to us growing the network. And there's lots of like vague ideas, but we're actually really thinking hard about this, because how we can make the network grow. I think most of proof of stake networks just like fixed on a single like economic model. But if we find a solution to create better economics for the participants of the network, maybe the network can grow faster.
Yep. Okay. Awesome. All right. So Artem, you ready? I'm going to give you a double whammy here, buddy. I'm going to pull a question up from the back up here because we're running out of time. All right. These are connected questions. First one's from Sasha. What is the role of the interchain messaging agent IMA in facilitating interoperability between Ethereum and Scale chains? That's part one. Part two, we know Scale just announced the Metaport bridge, and crypto bridges are the most common place to be hacked. What does Scale do to protect Metaport, i.e., what does IMA do to protect Metaport? That's from Duidong Ronald. So maybe just, again, one, what it really is IMA, and then two, how does IMA, what are things that are done to make IMA secure?
Yeah, for sure. Basically, thankfully, to D1 is already describes the architecture of IMA, but I wanted to add a couple of words that basically IMA is a native bridge on Scale, which doesn't take any kind of commission fee. Only fee which you need to pay is Ethereum fee when you are depositing some funds to Scale chain. But then when you want to transfer some funds between Scale chain and Scale chain, it's completely free. No commission fee, no gas fee at all. And with IMA, you can do something like funny stuff. For example, like recently we discussed one idea that you can actually be on a chain A and send one transaction to Europa and swap some tokens on Ruby exchange and receive the tokens back. So basically, it's like it's performed by custom messages of IMA, which is available to do right now. And then about the crypto bridges, actually, IMA is auditing all the time. I would say every time when we add the change to some smart contracts, we are running some audit, and also to have a bit more protection about the audits, we added some security methods to on Ethereum smart contracts. When you wanted to actually Scale chain owner can set it up for different with the different params. So and it would disallow some kind of huge transfers to be exited from a Scale chain, or rate limiting the transfers from one users. And everything is set out. It can be configurable, and that's it. Also, basically, all the IMA transfers is signed by BLS signatures, which is the same security which is Scale chain is running. So all the IMA transfers are running on the same security, which is actually a blockchain running.
Yeah, and I think that last piece is probably one of the main pieces, right? Is that a lot of bridges just have a central agent that is protected by a multi-sig that essentially says, "Oh yeah, send yes to this," and they kind of sign and send.
Mm-hmm.
There's not a central agent; it's a decentralized messaging proxy, and that's a BLS threshold encrypted message.
Yeah, and every time you need to collect 11 signatures. So basically, 11 parties need to sign this message. It's also different bridges collecting only 3 parties or maybe 5 parties. In our case, we are collecting 11 parties.
Mm-hmm. In an automated, decentralized way. It's the same parties that are participating in consensus. So if the consensus is accurate, then the bridging is accurate. Is really I think one of the big ahas of IMA. Stan, you want to add to that?
I just want to add several things. Yes, not even about scale, because some people maybe here not only use scale but something else. Just some security tips. I think every bridge there is always a risk, right? And there is no perfect security, so it's really bad to say. But probably there will be always, like, the history is that there will be always hacks, and especially in the blockchain world. And there's no perfect security. And in case of bridges, Vitalik some time ago, he wrote a paper about bridges, and he explained many things, I think totally correct in his paper. Bridge is basically, security of the bridge depends on the security of actually parties that actually control the bridge. In case of Scale, everything is totally open source. You know what's happening, as Artem just described, right? We have like 16 nodes. The nodes, you need to hack 11 of them, and all of them use SGX, which is also a very secure technology. Like most of networks use just store the cryptographic keys on hard drives. In our case, the keys are in SGX. But our mathematical model is fully clear, and it's like all on GitHub. And so the security, at least you always need to know how it works and understand the security risks. So Scale is one of very few bridges that is totally open source. There's nothing to hide. But other bridges, I mean, like there was this bridge which was hacked like a week ago, right? Like $1.5 billion, and no one knew how it worked. Right? Because if people don't open source things, in most cases it means that there is no security, it's just some people, quote unquote, that have the keys. And I read this paper like on CoinDesk, and it basically says these people were like arrested or something. They had the keys. So I, for instance, don't know how Polygon bridge works. I never understood this, and I never found any explanation. I don't know. Maybe people who use Polygon should ask Polygon how it actually works. So at least when you have security, it's important to understand the security risks. I'm not like a trader, but if I would be like trading, I wouldn't put too much money on Polygon bridge. I would probably be using like Bitcoin or Ethereum network. And different networks, have different security strengths. Definitely, at the moment, Bitcoin is very secure. On Bitcoin, people put like lots and zillions of dollars. Ethereum mainnet, people put zillions of dollars on it. With other networks, it's a trade-off. And Scale, we actually have less nodes than Ethereum. So there's a trade-off between security and speed. And we always tell our dev developers, well, if you develop a game, put your game on Scale. Then if one of the NFTs on the game becomes like a zillion, whatever, like Mona Lisa, probably you should move it to Ethereum, right? That people need to understand the risks. But one thing which we'll discuss a little later, I think one really important way to make things more secure for high value assets is to use zero knowledge proofs. And probably we'll discuss it later. But one of technologies to secure high value assets, not all value assets, but high value assets, I think are going to be zero knowledge proofs. And we are actively researching and thinking about these things.
Yeah, and we're gonna hold a special session to talk about zero knowledge proofs and Scale, because one, it's a community-led initiative. I think Stan and the core team, we get asked all the time, we should do this. So people have all these great ideas. How about doing this with Scale? How about doing this with ZK? So a lot of smart people have come together to come up with, I think, a cool way to do it within Scale. A lot of people from around the whole project, not just the core team as it should be. But we'll be doing a special session maybe next week, because there's news coming about how Scale will implement it, as we've been talking about it for a long time. So Stan, maybe you and I should just kind of take time to maybe even get some of the community devs together too, who aren't part of the core team, and kind of like do a roundtable talk about how ZK is going to take Scale, it really future-proofs things. I think right now we have phenomenal security, and ZK is good for, areas where you just want even greater security, but you're willing to pay for it and be comfortable with the latency. But one thing we can help with, little teaser, is just making sure that's decentralized. Decentralized ZK is where the future is. All right, so we're a minute over time. Just want to say thank you. This has been awesome. Hey guys, any last thoughts before we close up here? Artem?
Subscribe to our news. Like, we would have incredible news. So,
all right. Well, hey everybody, thanks for the questions. And again, awesome questions. And we appreciate your time and effort. And let's keep pushing Scale. All right. Bye, everybody.
Yep. Bye.
bye-bye.
Bye, guys.